All right, let's move into the assembling of our child booster seat. And the goal of assembling our parts, of course, is to mate them together into the way that the assembly would be constructed. But we want to constrain all our parts so that everything is locked down, so that none of the parts can be moved. Because since all of this is parametric and all this is tied together, if something in your assembly moves, the next time you open up your drawing file, it will update your drawing file. Okay, and that could be disastrous. So unless movement is necessary in your assembly, like something in the assembly is supposed to move, is supposed to slide or rotate or something like that, then everything should be totally locked down. When there is movement in an assembly, there are ways to constrain that movement so that it stays within the parameters of the assembly. And there's a resting point so that no matter what you've done with the assembly, it will always come back to the resting point, and that's what your drawing is based on. Okay, so I've started a new English assembly file. Be sure and pick the correct template. You don't want a weldment, you don't want a mold design, you want just the plain up assembly. And you notice there is an origin with the axes indicators here. Because right now it's just there. When you place your first part in an assembly, that establishes your axis orientation in the assembly. And the first part should always be grounded. So we're gonna bring in part number 1. So I'll go up here, place, and I'm gonna open up part number 1. And you noticed the XYZ axis indicator changed relative to part number 1, because this being the first part, it establishes those axes. All right, so I haven't clicked anything. I move my mouse over and I'll click once and it will include a second instance of that part number 1. So I want 2 of them. So I'll right click and go OK. Now, you noticed when I right clicked that, well, I can't do it now, but when I right clicked it, there were some options to rotate it 90 degrees based on Z, Y, X, whatever. If you brought in a part that doesn't line up the way you think you want it to look, you can rotate it now. Now, if you've set your options to ground first part in assembly, you'll get a pin on that part number 1. That means that part will not move. This one will, this one will not. Some companies prefer you to ground the first part. If they do not want you to ground the first part, and if you remember watching some of the CAD learning videos, he recommends against it, then when you bring your first part in, you have to constrain it to the assembly XYZ axes so that it will not move. The problem that some people run into is they bring in this part and then they rotate or move this part so that the views are no longer true orthographic views. And when they go to create their assembly drawing, their front view is skewed, or their right side view or a section view or something is skewed and it's not lined up properly on the paper. So your first part should always be either grounded or constrained to the XYZ axes. Okay. So now I want to bring in, I'm going to bring in the glue blocks. You can bring in as many parts as you want, okay? You can bring in as many parts as you want and then assemble it all, or you can bring them in one at a time and assemble them as you go. Either way, it doesn't matter. It lines them up in the browser in the order in which you bring them in. All right, now I noticed, because I worked on the first part of this video late at night, I made these glue blocks the wrong size. So I want to edit them here, and I just select it and right click. You can go to open and it will open up that file, or you just go to edit and you can edit it here in the assembly. See, it grays everything else out. So I'm going to come down here and I'm going to go show dimensions. Well, there we go. It should be 0.75 square. All right, and then I'll come up here and I'll hit return. And you notice that the little local update was highlighted until I hit the return button. So either way works. And you notice it did both of those. Now when I go to save this assembly, it will ask me if I want to update the part file also. And of course I would say yes. All right, so constraints. Okay, so constraints are a one-step process. You can do one constraint at a time. A joint is more complex in that you can do multiple steps at a time, but joints don't always work the best. Okay, you got two different tools here that you can use. Sometimes constraints work better, sometimes joints work better. So, but you have to get familiar with both of them. And for the glue block, because it has a little offset to it, we're just going to use regular constraints on it. Okay, so I'm going to go constraint, and what I want to do is I want to use a mate. You got all the different types here, so I'm going to use a mate, and my choices are mate facing or a mate flush. Okay, that's pretty obvious. So we're going to go with a mate facing, and I'm going to go inside surface there, and inside surface there, and doink. You got the nice little doink sound. Okay, and so that got it. Those two surfaces mated together. And if you notice the colors here, the blue and the green, when you look at your part, you can see the green is part, part number 2 that we selected. This part right here is not really blue, but kind of blue. Okay, and so I can apply that. Now I'm still in my constraint command, and I want to go flush with these two ends right here. Doink. Okay, so I'll apply that. And now the glue block here should be 0.25 down from the top of the vertical end piece. And so I'm still going to go with a flush constraint. And I'll choose those. And over here, I'll tell it 0.25. And the direction really depends on which part you pick first. Okay, so that raised it up. So I want to give it a negative 0.25 value. And that brings it down. And I can go, okay. So now that part is constrained in 3 directions. All right. So just to give you a little insight in how I check some of your drawings, if we go, let's see, I think it's on view. Yeah, degrees of freedom. And this little icon will pop up and show things that are not fully constrained. And so this tells me that this glue block is free to move in 3 directions and free to rotate in 3 directions. Okay, and same way with this part. So I will do this in your assemblies when I'm grading them to look and see what is not constrained correctly. All right, now another little thing here is these parts are grounded. You can't move them, but this part I can move it around. If I right click it, I can go free rotate, and I can flip it around any direction that I want. Okay, and it doesn't affect my assembly at all. It's just moved. So sometimes you'll bring it apart and you want to constrain it. You need to kind of finagle it around a little bit so that you can see it better. That's all I did. All right, so let's go back and we're going to do the same type of constraints on this part. I keep forgetting, you always got to hit apply afterwards. It didn't take it. Okay, so I can come right over here and I can double click that and it pops that up and I can go minus 0.25. Okay, now then, I know that, excuse me, ooh, I feel a sneeze coming. Okay, it passed. Um, I know that these are going to be flush at the top and flush on the side, so I can constrain those now, or I can constrain them to the part that's coming in later. Either way, they have to be constrained. So I can go ahead and do a flush constraint on the outside edges of those and on the top edges. Okay. And the only thing I did is I lined them up in this direction here. I can still move that further away. All right, so I'm going to save my assembly. And see here now it's asking me, do I want to save part number 3? Because I made some changes to it. So you can say yes, you can say no, whatever. Okay. All right, so now let's bring in, let's see, part 2 is the leg at the bottom. I'm going to bring in the tabletop first. Okay, and so here's an example of how, it might be easier for me if I rotate this thing. So I get it a little bit closer to my orientation. You don't have to do that, but sometimes you may want to. All right, so these, I'm going to go make constraint. I'm going to go to the top surface of the groove, to the top surface of that. I can do flush. But now it looks good, but it's not. So you see, I've still got that. I could slide it in that direction. So we still have to do a mate constraint here. All right. And I'll pause my video and you can do the other leg. Okay, so got those in, and I I didn't think to tell you there's no need to. All you got to do is constrain this thing widthwise this way to the slot because you've already got multiple constraints on the thing. And let's see, that is part 1, number 2. So let me look at that. So that's a glue block, the insert. Oh, that's the offset for the glue block. Flush to the other end, flush to the top. I did a mate up into the surface, and I did a flush on that end. Probably didn't need to do that one. That really over-constrained it, but sometimes Inventor will let you put extra constraints in. It's best if you don't. Okay, so now let's bring in the aprons. I'm going to go rotate Y 90 degrees. Okay, now then these are, I'll show you constraints and then a joint on this. So we can go constraint and we'll go flush top to top. And we can go flush end to end. And then we would do a mate. And you can do it on the face of the seat, the face of the base, either one works. Okay, so that's got that in. And so that's looking good. Now you can notice that all of these little axes lines are showing up. And those are coming from our part files. Okay, so if those are bothering you, you can go back in and turn those off for sure. All right, let's do a joint. Now, with joints, it does multiple constraints at one time. So you can do automatic, or you've got these options here. Now, the one we're going to do is a rigid, because we don't want this thing moving. It's not going to, rotate or do anything like that. So I want to connect this surface, this surface and that point to this surface at that midpoint. All right, now the offset on that would be the offset distance between those two surfaces. Now you can see that that thing is now totally, fully constrained. What was taking us 3 steps now just took us 2 steps, or 1 step, sorry. So joints have their purpose, okay? It's just a matter of using them to figure out the best way to do them. So now let's bring in this bottom piece here, okay? And let's place it. All right, and now then I know it's going to go, inside here and horizontally, so we'll go with a constraint. And I want to bring it out to no, I want to look at something here. We can mate planes. And so see there, we've got our XZ plane is going down the center of that part. And with our legs here, we've got a YZ plane going down the center of the part. So we can mate those planes to center things up. So that's what I want to do. So I'm going to do a constraint, and they typically work best with the mate, of course. And you can choose your planes you want over here. You don't have to turn them on. So I'm going to go with the YZ there. And it was the XZ there. Okay, and so you can see it placed it in the center. Now we've got to get our height. And this thing, while the drawings I gave you didn't say it, it should be 2 inches up. So we'll just do a regular flush constraint from the bottom to the bottom, and it's a 2-inch offset. All right. And so there we go. You can grab parts and try to move them. If you want to check things, you can go back to your view, degrees of freedom. And I turned it on. See, it's highlighted up here. It's on, but we see no little origin indicator. So it is fully constrained. It ain't going nowhere. And that's what we want, okay?